welcome to the next episode of our Google Earth Engine tutorial series. If you are new to this channel is dedicated to emerging GIS data layer and the Open Geospatial dataset. It's gonna share with you more insight about emerging GIS data that we could find online, as well as using them for environmental applications. Today I'm gonna show you how do we use Google Earth Engine for addressing areas that are of high conservation values. So one core dataset we will use today is this dataset, Areas of Global Conservation Important for Biodiversity, Carbon and Water. This is a dataset published a few years ago of about 10 kilometer resolution. It focuses on not only dimension on biodiversity, but also looking into the impact to the water system as well as the carbon storage. And all the pixel value are rendered with this priority rank here, so from 1 to 100. I encourage you to explore the dataset online as well as if you want to know more about the methodology, feel free to look into the paper. And also I want to voice out about awesome GED community data lot. This data lot holds a lot of very nice dataset in different environmental dimensions, including the dataset we were going to use today, which is the area of global conservation value. Here they have very nice documentation. What is this dataset about? What are the different bands that they included, and the setup of the whole dataset and so on. And yeah, feel free to check it out as well as the other dataset that exist in this catalog. For creating a forest mask, I'm also using the ETH Global Canopy Height dataset today for our application. So this is created by Nikunan as well as other researchers trying to have a high resolution global map on global canopy height. So yeah, let's jump into our application today. So what we will do is our output will be a visualization in Google Earth Engine, which we are trying to look for areas that are not only of high conservation value, but also vulnerable to logging activities. So this dataset is built up on the last episode, so if you haven't checked out the last one already, I encourage you to do so, where we learn how to map vulnerable forests in the Amazon rainforest. And there we use raw dataset and to create a cost model. However, today we will focus on how to make this visualization that what we see here. And the output, from what you can see, we have a speed map, and for all the data, they are put on the left side. And on the right side, we have the satellite base map. And if you are looking into the color polygon here, we are focusing on areas that are of high conservation value, as well as being vulnerable to logging activity. As you can show here in the satellite base map, we see quite some logging activity and deforestation going on, and that's how we can address them and map them to set up our conservation project. So let's look into how do we do it. So first of all, we have our admin 1, which is the study site that we are looking in. And what we are looking is the geoboundary dataset here that are hosted also on the community catalog. We try to look in the study area of Brazil, and that's why we filter our polygons to the ISO code BLA, which is basically representing Brazil. And then this is our geometry for the whole application. And there are different setup for this conservation value data. And here I'm only looking in 4 different layers, which is the biodiversity layers. The biodiversity combined with carbon, combined with water, as well as both. So then we have our 4 EE images here. We set up a general visualization parameters, as well as I set up a specific color parameters for the different layers, as we want to kind of combine with layer transparency to showcase different layers in parallel. So we have our biodiversity layer in this red color, this water in blue color, and carbon carbon in green color. So as you can see in the output, we have a speed map. And in order to do so, we have to set up two UI map components. So the left map and the right map. And we will use the map component on the left for all our data layers. So we add the data layer that we imported with our visualization parameters, and we are not showing it at the moment by default. We add all the 4 different layers. And the next section here is from our last episode. So we tried to use the global fishing service to create a cost model which calculates the vulnerability of our forest. Here we set up a threshold for creating like a mask, and all layers I'm using a focal mean in order just for visual smoothing effect. If you don't want it, you can also don't use it, it's optional. And for vulnerable, I'm using the model that we create to create a mask. And for the forest mask, I am using the EDH dataset for canopy height that are higher than 5 meters. That will be included. Otherwise, it will be excluded from our visualization. On the other hand, we are creating another mask using this Biodiversity carbon water dataset. And for all the areas that are from the ranking from the 1st to the 30 percentile, we will include it in the visualization. So it's more like the more important, both biodiversity-wise or carbon or water-wise, it is important. So I will create. I will also put a mask on this as well. And we have 3 different criteria. We try to combine this with the N keyword to have vulnerable forests that are of high conservation value. We have a mask here, and we will use this together with the update mask function for our data layers. So we visualize our data layer with the mask for the different data layers here. And here I'm using some transparency for the visual, so we can show different layers together with their colors. And one also more important thing is when we trying to adjust a conservation project to set up the area, we also have to look into how current protection is look like. And that's why I'm using the feature view layer of WDPA, Global Database for Protected Areas here. So we could also put it on the map for references to understand which area are already protected and which area are not. So for the feature view layer, we have to set up like visualization parameters. I am setting up here with the dark gray color, so the same color as the base map. So it kind of like block out the original areas that we have to try to create like a visual mask that we can focus on the area that are unprotected for our visualization. We set a length for the layer and we add them to our left map as well. Finally, I also want to show the polygon of Brazil. So we have a geometry, and here I am setting up like a white polygon. So with a boundary of white color and fill color, I will put it to transparent so that we only see the boundaries, and we also add them to the map as well. For the visual, I'm using a custom base map here. You can also play around with the values yourself, but basically I just tune down the saturation, so we have the grayscale as well as some tuning in the lightness. Then we can actually customly change different parameters to decide how do we want our custom base map to look like. So on the left side, we are using the grayscale base map, and on the right side, because we want to compare with a satellite data, like with the base map, that's why I'm using satellite here. And I try to use a linker, which is a map linker for putting the left map and the right map together. So when I zoom in and zoom out and try to pan it around, they will move together. so we can do a better comparison. Afterward, we have to create a speed panel. So this is another UI component. What we need to do, we just need to have our first panel, which is the left map, and the second panel, which is the right map. And we need to decide on the orientation of the speed map as well. I set it up here with a stretching style. And with the UI root here, I'm basically clearing all the existing map components here and to put the speed map on top. And that's what we are doing here in the next line. We add the speed map on top and we center the object for the left map, but the right map will also follow as they are linked. And let's look at our result. So we have the polygon here for the boundary of the state. And if we don't look at the satellite base map for now, we have different layers. We have our protect area, which is in dark gray color. So it broke out the color that are already protected, which might not be our focus for conservation project. And we have the different dimension of conservation value, including biodiversity, carbon, which is in green, and water area. So we can also zoom out a bit to see the whole country. So as you can see here, if we're only looking in biodiversity, we have a lot of sites that are of high conservation value, let's say in the state of Amazon, but actually even more so in the south. However, if we are not looking to only biodiversity, but only like biomass with carbon stored, then we see the main focus is in the state of Amazon here with many different areas. And this pattern here are mainly related to the road and how residents having logging activity along the road, and that's why this is more like a vulnerable area. And if we combine them with a satellite base map, we can have a better overview of how the area look like. So we have the road, and along the road we see the whole area is mapped up, particularly for example with the hotspot here. So feel free to run the code and play around yourself. And yeah, I'm happy and looking forward to see you in the next video. See you.